Hey everybody, it's Dr. Eric Balcavage. We're back for another edition of Thyroid Thursday, and today we're talking about GLP-1. And everybody's talking about GLP-1 agonists, and they're good for weight loss and blood glucose, and there's people singing and dancing on TV. But I think there's a couple questions that we have to ask when we talk about GLP-1, and that is, why do all these people need GLP-1 agonists to begin with? So let's talk about the GLP-1. No one is talking about it. Everybody's talking about the GLP-1 agonists, and they're talking about GLP-1 and its impact on blood glucose regulation, and they're talking about what's happening in the GI tract, but there's another one we need to talk about. So first, let's talk about what GLP-1 is that everybody's talking about. Within minutes of eating, your L cells in your intestinal tract release this hormone called GLP-1. GLP-1 goes to the pancreas. It decreases glucagon production, and it increases the release of insulin, especially the first phase of insulin response, which preformed insulin. So that way, as blood glucose is going up, insulin is rising with it, so it doesn't rise too high. The glucagon that's typically released by the pancreas that is what drives the liver to push out glucose so that our glucose is maintained in a fasted state. So when you're eating a bunch of food, your body wants to kind of decrease the production of extra glucose because we got glucose coming from our food. And what is thought with people that have high blood sugar, that have the prediabetes and diabetes, is if you just give them GLP-1 agonists, this medication that binds to these GLP-1 receptors, then you'll get more shutdown of glucagon, you'll get more shutdown or more stimulation of insulin production. And that can help with weight loss, it can help controlling blood sugar values. But I guess a couple questions we have to ask is, why was the GLP-1 low to begin with? Why was the GLP-1, if they were not working well enough? And is adding more GLP-1 to that system really the best scenario? And I don't know that that's necessarily the case, but the most important thing is it doesn't address the cause. And sure, some people don't want to address the cause. We're just trying to treat the problem. We don't really care about the cause. Maybe, but there's another GLP-1 that may have a bigger impact on why we don't have GLP-1 being released appropriately to begin with. And so that's central GLP. So GLP-1 that's being talked about on TV and T commercials is what's being released from the GI tract. What I'm talking about is what's being made and released in the brain. And when there's GLP-1 released in the brain, that impacts satiety signals. So there's this hormone called leptin. When you're storing extra calories in your adipose tissue, the adipose tissue releases leptin. Leptin can increase the release of central GLP. Leptin goes to the brain, tells the brain, hey, we need to release this central GLP-1. And that GLP-1 that's released in the brain triggers greater satiety cues. So that way we're not hungry. And so that's kind of how this whole process should kind of work. But this is an important piece. There's something else that increases GLP-1 centrally in the brain. And that is that's some type of a stress, emotional stress, maybe some type of inflammatory trigger impacting the brain is going to cause an increase in that central GLP-1. And that should shut down satiety, which sounds good, I guess, but that increased central GLP-1 increases something we call the sympathetic nervous system. That's your fight or flight response. And that increased sympathetic nervous system is going to wind up in a decreased parasympathetic nervous system. So GI tract gets kind of shut down. We're in stress, we're in danger, we don't need to digest food. And if we decrease the parasympathetic nervous system, we're going to get decreased intestinal function. And part of that is that probably we're going to get decreased, guess what? GLP-1. So maybe one of the reasons why these people with diabetes and blood sugar problems and obesity have maybe low GLP-1 is because they've got some type of chronic stress, chronic inflammatory process going on that's impacting the central nervous system. And because they have decreased GLP-1, when they eat food, they have increased blood glucose levels because there's not enough intestinal GLP-1 to rise insulin and not enough to turn off glucagon. And so the liver still keeps pumping out glucose. That central GLP-1 can also activate the HPA axis. That's the hypothalamus pituitary adrenal axis, which drives increased ACTH production, and that increases cortisol. Now, what is cortisol going to do? Cortisol is going to increase blood glucose production. That's not it. That increasing of the central nervous or the sympathetic nervous system is going to increase epinephrine, one of those fight or flight catecholamines. What's that going to do? It's going to increase blood glucose. And there's another thing that we have to take into consideration. When we have that stress and that inflammatory process in the brain, it increases the conversion of T4 to T3 in the paraventricular nucleus of the hypothalamus. That results in a lower TRH, that results in a lower TSH, and a decreased T4 to T3. So what might that look like on a blood panel? That may look like somebody having hypothyroid signs and symptoms, but a low TSH. And if TSH is the only thing run, TSH with a reflex to free T4, if TSH is low normal, then the person could be complaining of hypothyroid symptoms. The person could be overweight, they could have blood sugar issues, but they're gonna have, if we did the rest of the panel, maybe their T4 and T3 levels are low. Lastly, when you have this decreased peripheral T4 to T3 conversion, because there's less T4 in the system, because there's this inflammatory process going on, there's less T3 in some of those peripheral cells and tissues, like the GI tract. And if there's less T3 in those peripheral cells, what's it going to result in? It's going to result in decreased glucose transport into a cell, decreased insulin-dependent glucose transport in the cell, and what's going to happen is you're going to have more blood glucose. So what does all this mean? This means that maybe we're focused on the wrong GLP-1 stimulation. Maybe we have to think about what's causing this whole process to shut down to begin with. And maybe the reason this whole process is being shut down is because people have a lot of physical, chemical, emotional stress that's impacting their brain and causing their brain to shut down the digestive process on purpose because it needs to defend itself. So if we spend more time worrying about what's happening, what's creating that excessive stress load on our physiology, that would probably be the most important thing we could do. And maybe we wouldn't need all of these medications that really don't address the underlying issue. If you have any questions, put them below wherever you watch the video. All right, take care.